permanent magnets in synchronous machines. What are the different permanent magnets schemes in synchronous machines, and what are the advantages and disadvantages of these types. Then we will discuss the last part of dynamics of synchronous machine, and hopefully to finish this today, inshallah. So starting, Shabab, from permanent magnets. You know, Shabab, the excitation in synchronous machine is very important in order to establish the flux. We have two ways, either using windings, like brush or brushless excitation, or using permanent magnets. Permanent magnet is also a good solution. However, take care, permanent magnets are not preferred in hot area. Here in GCC, we shouldn't depend mainly on permanent magnet machines, because the machines will or magnets will be demagnetized after a certain time, which means the lifetime of the machine will be less if we compare it to induction motor or base field winding synchronous machines. تمام؟ تفضل.
I think the permanent magnet used for small machines, not large machines, right?
It's not a condition. Actually, there is or there are many synchronous machines, even in power plants, they use permanent magnets in their flux to establish the flux. Okay, but they use it in many steps. It's not one step, and with a huge number of permanent magnets, and maybe 60 or more than 60 magnets per machine. Okay, so it can be used for high power. No problem to use it for high power as well. And this is now the modern fashion in electrical vehicles. All of electrical vehicles now are preferring use of permanent magnet synchronous machine. تمام؟ طيب. So starting from the beginning, permanent magnets is the magnet that can be used in order to establish the flux. Type how we can insert these magnets in machines. This is what we are going to discuss now. Firstly, there is a type called surface mounted magnets. طبعا يا شباب we have armature winding in stator. We prefer to put the armature winding on stator, and the magnets will be inserted in rotor structure. It's different to DC machine. In DC machine, if we compare permanent magnet DC machine or based field DC machine, you will find armature winding are on the rotor side. However, the field winding or permanent magnets are inserted in stator. Here in synchronous machines, we add the permanent magnets on rotor. First structure is surface mounted. Surface mounted means this is the motor, this is the rotor surface. So this is the cylinder of the rotor, okay? And on the surface of the rotor, we will insert the magnet like that. Here, okay? This is simple structure for a two bare poles permanent magnet machine. طيب. طبعا يا شباب, the rotor structure seems salient, صح ولا غلط؟ Is it salient or cylindrical now?
There are some gaps.
There are some gaps, so it should be salient. However, the permanent magnet is considered like air gap. The magnetic reluctance of the permanent magnet, and it has permeability equal to the permeability of the air gap, almost unity. So for this, Shabab, we can consider that this type of motor has almost like cylindrical type, where LD equals LQ. So this is the advantage of this configuration. However, we have some problems in this shape. First, Shabab, at high speeds, because there is no any thing to catch the or support the magnets, it's only glue used by using glue here in order to fix or fasten the magnets in the shaft. We have many problems. First, since the magnets face the rotating air gap flux, and eddy current losses caused fast demagnetization. So it will be fast demagnetized, Shabab. Why? Because it's in the surface on the rotor, and this is already the place of rotating field. So there will be a lot of eddy current loss here in these magnets, and this is going to demagnetize these magnets fast. So this is the first drawback. Secondly, the fastening way of the magnets here are affected because of the heat. We should find another way in order to reduce the losses or reduce the eddy current loss here. So these are the two drawbacks for the surface mounted type. We have another shape called inset magnets. For inset magnets, شباب, as you can see, this is the rotor structure. You can see that we have here some wedges of the rotor itself, which helps to support the magnets. تمام؟ يبقى here the dashed part here are the rotor core. تمام؟ This is the magnetic material of the rotor core. طبعا اللي في النص ده شباب اللي هو الايه الشافت بتاعنا. ماشي؟ And these are the magnets. معرفش انا ممكن اغير اللون بتاع ال pointer. مش عارف ممكن ولا لا. whatever. As you can see here, شباب, the magnet is inserted between the wedges of the rotor parts. So you expect here to have different reluctances. So we have here LD and LQ. تمام? So this is better here, شباب. Having LD and LQ, actually this is better because it will improve the torque performance, because we have now reluctance torque. We have a component of torque due to saliency. So this is better for us now. طيب. So the advantages here, شباب, there is a saliency. For a small size magnet, the peak torque developed with inset magnet is higher than that of the surface mounted magnets. So compared to surface mounted, this has better torque performance because of the reluctance torque due to saliency. Also, this type of rotor structure is more robust and has same applications as surface mounted. طبعا more robust because now we have wedges around the inserted or inset magnets, so it will help to increase the lifetime of fastening of these magnets. However, we still have some drawbacks. First, still we have the magnets on the placed across the air gap, so we still have the problem of fast demagnetization. This is number one. Number two, fastening of magnets are affected also because of the losses due to eddy current. طيب we still have the same drawbacks يا شباب of the previous motor, previous insertion of magnets. However, this one is better due to the saliency, due to the torque, the better torque performance. So we have another solution which is called interior permanent magnet, okay, or period permanent magnet, which means we insert the magnets inside the rotor structure. This is one shape. It may be also like that, يا شباب. Insert the rotor like that. Okay, it has many shapes. طبعا يا شباب, how we can select the proper shape, it's based on our design. all of these يا شباب, all of these machines have to be firstly designed on programs using finite element methods calculation on programs like COMSOL, like ANSYS, any multi-physics programs that can give the performance at different configuration, and start by using optimization techniques, select the best way to insert the magnets inside the rotor. Okay, شباب, to reach to the best design. طيب, what is the advantage now of the interior type? First, in this arrangement, the magnets are buried inside the rotor structure. طب ده هيعمل لنا ايه الاضافه هنا with radial magnetization. First, it's radial magnetization, not axial. It's inserted inside the rotor as the same direction of radius of the rotor. تمام? This is going to decrease the area of magnets in the air gap, or may remove it if it's inserted inside like that. تمام? So this is better in fastening. It will not have the eddy current loss or high eddy current loss, like what we have in magnets at surface or inset type. However, here in this motor يا شباب, due to the shape of the motor and design, we will find that LQ is greater than LD. And this is actually good because it's changed the performance and getting much better torque performance here compared to previous types. For that, we prefer the use of these types in the applications of electric vehicle يا شباب. Okay, due to the additional reluctance torque, and we have LQ here greater than LD. تمام. So this helps to improve the performance of machine. تمام. So
I think
the best
Tesla company uses this idea.
Which one? The interior magnets?
Yes.
Yeah,
I saw a
actually
video
this
from
is,
the engine.
yes, actually this is the best one used. they should use it actually. طبعا يا شباب every day we have improvement in electrical machines. All of these types of machines يا شباب are called radial flux machines. We have modern type called axial flux. We have motors have two rotors, not one rotor. It's called double rotor. But these types are still in the investigation process. And if we reach to a robust design, for sure, the companies will start promoting these designs and start making this in their vehicles. طبعا دايما يا شباب there is a gap in time between research and industry. Research may elaborate in a topic for maybe 20 years before finding this in industry. ماشي. If you have a look to something called T-type inverter, this is one of my work, by the way, T-type inverter. I made this type of inverters at 2011. Okay, شباب. Now we are in 2021, it's 10 years, and it's not used yet in industry. However, there are some companies produce some samples. So 10 years, even 10 years are not sufficient. It may be found after 10 to 20 years more. This is the normal in industry يا شباب. Even T-type inverter has very good performance compared to current converters, current multi-level converters. It has lower losses, it has better long lifetime, and so on. This is one of the of the work in power electronics converters, very very good achievement. However, as I discussed with you, it's not appeared yet in industry. Also, some colleagues are working in axial flux machine. Now it's around 5 or 6 years working in this type of axial flux machines. Some people working in Finland, some are working in Belgium, some are working in Italy, some are working in Egypt with well-known professors and well-known teams in electrical machines. However, it's still in investigation process. It can be started in process of industry to be a product maybe after 15 or 20 years. And also it depends شباب on the how the products are moving in the market. Electric vehicle, by the way, it's just still starting. Okay, how much electric vehicles we have in the world now compared to base heat engine, or let's say not only pure electric, even hybrid. It may be less than 10%. صح ولا غلط شباب؟ for that you will find it will take long time to be used. فده الحال دايما بالنسبه لايه العلاقه ما بين الريسيرش والاندستري. Any question شباب؟ طيب okay. We have some comparison here شباب between permanent magnet machines. طبعا شباب permanent magnets in PLDC in PL we stated PLDC in the last class. PLDC is brushless DC, and we said brushless DC, it's called DC because the supply is DC. supply of the inverter, which convert DC to AC. However, it's mainly synchronous motor. But what are the advantages of PLDC compared to DC motor and induction motor? And by the way, here you will find in the previous slides, this was written as induction. Please correct this in your slides. Compared to DC motors, شباب, comparing PLDC with DC motors or synchronous machines with DC motors, you will find that PLDC are small rotor size, high power density. Okay, طبعا this is because of the absence of the commutator. No commutators are used in synchronous in brushless synchronous machine or PLDC. Also, lower inertia and faster dynamic response compared to DC motors. High speed and torque capability due to absence of brushes and sparking. Lower maintenance, high torque inertia ratio, better heat dissipation due to the stationary armature winding. طبعا in rotor, in DC machines, armature windings are on rotor. However, here armature windings are stator. So just have armature or stationary armature winding, this is better in heat dissipation. Okay, better also in overall reliability and life. So comparing DC motors with synchronous, the synchronous is much better. Like comparing synchronous with induction, شباب, you will find that synchronous has higher efficiency. طبعا because in induction motor we have slip power loss, which are in the rotor circuit. However, here we do not have this kind of losses because the machine is working with the synchronous speed. High power and torque density because of high air gap flux density. Lower operating temperature because of lower losses compared to the induction motor. The disadvantage or drawbacks of PLDC, شباب, PLDC motor drive systems require a rotor position sensor. And even this now, شباب, we have many techniques used to control the machine called sensorless control techniques. Sensorless control techniques means we don't need any position sensor. We can just sense the current and voltage in order to control this machine. And also in induction or any kind of other machines, we have to sense voltage and the current. So no need for position sensor for advanced control techniques like model predictive control, like direct torque control with sensorless. Okay, شباب? So even this, I can say here it's old a bit because now we can work as sensorless. تفضل.
Why do you need the sensor?
In order to operate this kind of machine, these kind of machines are not self-started. So in order to operate the machine, you have to align the axis of the machine, the rotor, with the stator flux. This is very important in the beginning. If you did not make that, you will have acceleration, and this will consume more power and may damage the machine. Will take much more current. So you have to firstly assign the position of the rotor axis according to the flux, the stator or rotating flux. This is very important. This is for all of synchronous machines, شباب, permanent magnet or normal synchronous machine. This is for closed loop control. Okay. طيب. This is number one. However, as I discussed with you now, this can be managed in modern control techniques because of what? Because of sensorless. If you type sensorless on Google, you will find a lot of methods for sensorless control or speed control of permanent magnet machines. This is number one. Number two, complex power electronics. It needs power electronics and the complex controllers resulting in higher initial system cost. طبعا this is also شباب طبعا الكلام ده شباب موجود في الريفرنس however this is also old a bit. Why? Because no electrical machine is working now without power electronic converter. All of electrical machines are controlled using power electronic converters, and power electronic converters now became very cheap. You can find power module for power module for instance 1200 volt and around 40 ampere. The cost of this is almost 20 USD, $20 only. It's very cheap. Okay, so if we get the power module and start adding some controller and so on, it may add the cost will increase for sure. However, the power module itself it became very cheap now compared to the old or conventional converters. تمام. So the technology is developed day by day يا شباب. Every day we have new in the power electronics and the new in machines. So the problem of cost, for sure it will be a decreased, the cost will be decreased, or the problem will be eliminated due to the bulk production or the mass production of these types of technologies. Type. So I think these drawbacks is also almost vanish or will be vanish with time. Number 3, there is a possibility that demagnetization of permanent magnets may occur due to accidental overload or fault. This is actually exist, and we have to find some ways to prevent or to protect the permanent magnets from these overloads or short circuit or whatever. However, we still have also, as we discussed from the beginning, here in our countries, due to the high temperature, the high ambient temperature in our exposed applications or outdoor applications, you will find that it's not easy to operate machines with permanent magnet for long lifetime. تمام يا شباب? For that, it's very important here in our countries to provide our technology, because outsiders will not make special things for us for free. It will be much more expensive. If, for example, يا شباب, Tesla company makes a car based on permanent magnet PLDC motor, it will be used worldwide. However, the lifetime of the motor will be less here in Saudi Arabia, for instance. So they can provide a special motor for you. However, the cost will be very high because it's customized solution. تمام يا شباب? So it needs effort from our side as engineers in order to improve and develop motors for our needs. Hi. To be honest with you, شباب, the matter of machine design was disappeared from 20 years. If you go back 20 years ago and you ask anybody, you work in research and in certain area, if you find someone working in design of electrical machines, it's a jockey. Why you are working in design of electrical machines? Everything was stable. However, now it became very important due to the applications, due to the new applications. So working in electrical machine design now became very, very important. Any questions, Shabab? Okay, so this is related, this is regarding the permanent magnets. You will find also another comparison here for synchronous and induction. However, we may leave this for you, just read it, and we will comment this inshallah after discussing all of the induction machine topics. Fine. Then we have some questions, Shabab. We will answer this question together in the help session inshallah. So I will leave this part now and start in the other part, which is related to the dynamics of synchronous machine. Previously, Shabab, we discussed the dynamics of synchronous machine, and we discussed the stability analysis for single machine infinite bus. This is the single machine infinite bus, what we discussed recently, and we got the curve here, and we derived the stable region together using the dynamic equation. Today, we will focus a bit on the swing equation, which is a dynamic equation, basically dynamic equation, and we will reformulate this equation to represent the relation between power and power angle. Derivation is not required. Okay. However, I will go fastly through the derivation. Starting from here, Shabab, you know the relation of dynamic equation, which is T mechanical minus T electrical equal J d omega by dt or d square theta by dt square, where J is the moment of inertia of the machine, Te is the electrical torque, Tm is the mechanical torque, and theta is the angular displacement of the rotor. mechanical طبعا mechanical angular displacement. تمام. طبعا displacement of the rotor compared to the stationary axis of the stator. طيب. طبعا T is time and so on. And here an example to understand the dynamic equation we already discussed before. If TA يا شباب, which is the difference between Tm and Te, is 0, this means, is there any acceleration?
No.
So this means now the machine or the synchronous machine is working at 60 hertz, which is the rated frequency in our country here. طيب, what will happen if TA is greater than 0? So in this case, this term will be positive, which means there will be acceleration. صح يا شباب؟ طيب.
Yes.
We discussed before that there is a system called the speed governor. Speed governor will elaborate or work with this equation until reaching to TA equals 0. This is the target all of time with the speed governor, شباب, to achieve 0 acceleration. So instantly, if you have suddenly change in load, speed governor has to start working up till reaching to TA equals 0. Otherwise, if TA is not 0, this means speed governor is still working or still in duty. تمام يا شباب؟ طيب, we are going to discuss more in details today إن شاء الله شباب in transient, in the period of transient itself. So this means that the speed governor is still working. He did not achieve the steady state yet. تمام? So we are going to move in deep during the period where speed governor is still working, where we have T electrical greater than or less than 0. طيب, starting from the equation يا شباب, theta m equals omega s m multiplied by T plus delta m, where omega sm is the mechanical synchronous speed in radian per second, and delta m is the mechanical angular displacement of the rotor. تمام يا شباب؟ From this angle, we can say, if we differentiate this equation, so d theta by dt will be equal to omega plus d delta by dt. And if we make double integration, it will be d theta by dt, d square theta by dt square equals d square delta by dt square. This is very important, which means now the acceleration of the machine equals d square delta by dt square, because delta will represent power angle later. So it's very important to recognize that the acceleration is the same value as d square delta by dt square. Right. Returning back to the dynamic equation again, we can replace d square m, d square theta by dt square by d square delta by dt square. So J d square delta by dt square equals TA. Now we can multiply the two terms by omega m, which is the change of theta m. Okay, so if we multiply change in displacement, which is omega, this is nothing but, if we multiply omega by t, this is nothing but power. So we can say now j omega d square delta by dt square equals PA, which is PM minus PE. Now, شباب, there are many definitions for inertia, many inertia constants. One of them is m. M is equal to j omega m. Okay, so we can replace j omega m by m, or we can define another constant which is mostly used, which is h. H constant is nothing but stored kinetic energy of the synchronous machine at the synchronous speed divided by the generator rating. And I don't know why the font appears like that when converting Word to PDF. طبعا this is شباب generator rating. There is a space here. Okay, so this is the apparent power. So H is defined as شباب kinetic energy over the apparent power. And kinetic energy can be represented by half J omega square, and the apparent power is S. So the units of H now is nothing but this is joule, صح ولا غلط شباب؟ energy measured in joule, and S is measured in volt ampere. So it's power. If we divide joule over power, it will be time. So the units of H is second. Time. Now we need to use H in our
Doctor?
relation. تفضل.
The kinetic energy is for the rotating part, the
Yes.
shaft.
Actually, kinetic energy is all of time for rotating mass. تمام؟ which
Yes.
is
Yes.
our rotor يعني. تمام؟
Yeah.
So now شباب we need to represent H in our relation here as a function of the dynamic equation. So we will replace J omega, or we can use يعني either M or J omega, يعني the same definition. But we will replace H by this part in our relation, or remove J and يعني هات J في طرف لوحده، يعني make J for instant in the right hand side and move other parts, transfer other part to the left hand side and replace it here in our relation. So the final relation يا شباب will be like that: 2H over omega d square delta over dt square equals B over S. طبعا B over S يا شباب is nothing but power in per unit. صح ولا غلط؟ It's power over apparent power. So this represents
Yes.
power in per unit. Right, let's represent our equation in per unit and also convert from mechanical to electrical angles. So you know electrical angle all of time equal P over 2 multiplied by mechanical angle. So we can say now 2H over omega S equals d omega over dt multiplied by PM minus PE in per units. So simply طبعا delta now يا شباب is the electrical degree of the power angle, and omega is the electrical synchronous speed in radian per second. So we can now say يا شباب the relation 2H over omega, we can even replace omega by 2 by F. Okay, so it will be H over 2 by, sorry, H over by F d omega by dt multiplied by PM minus PE, or instead of d omega by dt we can add d square delta by dt square. So this is now the final relation we need يا شباب. This relation is nothing but the relation of power and power angle in terms of H constant. تمام? This is important to be used for stability issues. We will see inshallah in an example how we can use it. We have just a few comments شباب on this relation. The plot of delta versus time يا شباب is called swing curve. Swing curve. It's important شباب in the stability of power system. يعني إن شاء الله if you take the course of stability of power system you will learn exactly the swing curve, and يعني this part will be discussed in more details. تمام? So this curve is very important شباب. The mechanical input power PM is in the swing equation is considered constant. Why يا شباب? We said we are going to discuss the relation during the transition periods only. And we discussed it before, electrical time constant compared to mechanical time constant is very small. So if you have a short circuit, for instance, short circuit time يعني has to be very small, and you have to clear this short circuit very fast. So we can consider during this period PM is constant. However, PE will be changed. And also we said during the transient شباب, we should consider that the speed governor is still in duty, still working to achieve the acceleration or make the acceleration equal 0. تمام? Or d square delta by d square equals 0. This is the target of the speed governor. So during the transient stability, we can consider that PM is constant. تمام يا شباب? Because the mechanical time constant for such high power system يا شباب is very high. It's very huge. الانيرشيا شباب بتاعت الجنريتورز يعني it's very high. تمام. يعني انا مش عارف يعني I'm not sure if you could see a real synchronous generator before or not. يعني if we مثلا يعني شباب if we have generator of 300 megavolt ampere, the shaft length may be around 13 meters. The diameter of the stator may be around 2.5 meters. يعني it's very huge system and the inertia is very high. تمام. So change in electrical system is very fast and change in such huge inertia mechanical system is very slow. So we can consider B mechanical is constant. Also, if PA is 0, this means PA, which is the acceleration power, it means B electric equal B mechanical, and the machine operates at steady state. طبعا this is we discussed this before. يعني these are some notes. Also, changes in PE could result from severe load changes, like faults. Okay, like huge load, turn it on or turn it off, and so on. So this considered as يعني severe loads and change in PE يعني should be considered for such cases. The solution of swing equation is very difficult even in case of single machine infinite bus. So يعني it needs شباب يعني huge computing in order to fulfill that. يعني we have here few questions يعني we can يعني solve it together. For instance شباب يعني طبعا the answer is given here. يعني for a synchronous generator, if the mechanical power input increases, instantaneously the machine will, what will happen يا شباب if the mechanical power increase? Will operate at constant speed or will decelerate or will accelerate? طبعا if the machine mechanical power increase, this means P mechanical minus P electrical will be positive, which means d squared delta by dt squared will be positive as well, which means the speed has to be increased or accelerate. صح ولا غلط؟ تمام يا شباب؟ Is it clear?
Yes.
طيب question number 2 اتفضل.
What's the mathematical relation between the power and the electrical power, between the synchronous generator speed and the mechanical electrical power?
This is a relation. What we have derived now. P mechanical minus P electrical equals H over pi F multiplied by d squared delta over dt squared. D squared delta over dt squared is the acceleration. So if you have B mechanical greater than B electrical, so this term will be positive, which means d squared delta by dt squared is positive. Positive acceleration means the speed is increasing. صح ولا غلط؟
صح.
However, negative acceleration term or negative power acceleration means the machine is decelerating. صح كده؟ So يعني swing equation is nothing but dynamic equation يا شباب. But يعني here we use different parameters. طيب, for a synchronous generator, if the electrical power increases instantaneously, the frequency will increase ولا decrease هنا يا شباب? If electrical power is increased,
Yeah, it will be, the acceleration will be negative.
Exactly, which means the frequency will decrease. تمام؟ طيب, if I did not mention instantaneously and I asked you at steady state, what will happen? Should we say the frequency will decrease?
No, it will correct itself.
Exactly. This is by means of speed governor. So the control system will start working until reaching the steady state again. تمام يا شباب? For that, يعني actually this sentence was in a reference without the word instantaneously. I added this word here because it's very important to be recognized. Here we are working in transient, not in steady state. طيب. طبعا the swing equation can be expressed in degrees. طبعا يا شباب يعني in degrees, this means delta in degree. So pi should be in degree, not 22 over 7 صح? Should be 180 صح? So we can use this relation in degree. However, this relation in radian. Okay, شباب. The machine operates at steady state synchronous speed when طبعا we said when PE electrical power equal PM. تمام يا شباب؟ يعني this was يعني the dynamics part. What we need to discuss here, we have only one يعني fast example. يعني in the slides شباب, I just added the notes of relations. However, the revision is given in another slide, and here we have some notes what we already discussed in the other file, and I shared the other file with you on Blackboard. Right. We have here solved example to see the benefit of using this swing equation. 60 Hertz synchronous generator having H constant equals 5 megajoule over megavolt ampere, and a transient reactance XD prime equal 0.3 ampere unit is connected to an infinite bus as shown in the figure. So we have here the figure, شباب. We have synchronous generator connected to a transformer of 0.2 per unit reactance, and we have two transmission lines, and finally it's connected to an infinite bus of V equal 1 per unit. Right. Then it's stated here the generator is delivering real power of 0.8 per unit and reactive power of 0.074 per unit to the infinite bus. So this is the amount of P and Q at here at bus number A2. تمام يا شباب؟ Find the power and power angle equation. Power and power angle equation is nothing but the swing equation that we already have described now at this operating condition. So simply شباب, we can now say the transfer reactance. First, we will collect all of the reactance. We have 0.3 for the generator, 0.2 for transformer, and two parallel transmission lines of 0.3. So the resultant X or the total X will be 0.65. Now we need to substitute in the equation. In order to substitute in the equation, we need delta. In order to get delta, power angle, we need to get E. And in order to get E, we need I, the current. So starting from the apparent power, S is given as 0.8 plus J 0.074. We can get current. We have V equal 1 per unit. So we can say, you know, S equals VI conjugate. So I equal S conjugate over V conjugate. So this will be the current in per unit. Now substitute in the equation of E equals V plus JX and use the overall X, okay, because we have the volt of the infinite bus. So finally, you can get the value of E and power angle. Now we need the power angle. Power angle is 26.39 degrees or 0.46 radian. So we can now write the relation of power. You know, B maximum equals EV over X. Substitute in the equation by EV and X. You will get the power is 1.8. This is the maximum power. If you multiply it by sine angle of 26.39, it will be 0.8, which is the given value of power. However, we need the equation, so we can say now the equation of power P equal 1.8 sine delta. So this is the relation now of power and delta. Number B, if a three-phase fault occurs at bus 1, write the swing equation during that fault. So we need now to write the swing equation at fault at bus number 1. Bus number 1, which is here, شباب. So for the faulty case, شباب, if we have fault, this means V equals 0. And V equals 0 means power equals 0. So we have electrical power equals 0. What about mechanical power now? Is it 0 as well? Hi, شباب. Is the mechanical power equals 0 here? Or we said during the transient, mechanical power should be constant?
Yes, should be constant. Yes.
Should be constant. So mechanical power will be the same before of the short circuit, which was 0.8 per unit. So we can say now at this case, the equation of swing equal H over pi F node d squared delta over dt squared equals Pm minus Pe, which is now 0.8. So this is now our relation during fault. C, calculate the initial acceleration. So initial can be obtained from our relation. Acceleration is d squared delta over dt squared. Substitute now in the equation of d delta, which we already have here, d squared delta over dt squared. We have h, we have frequency before of the fault, which is 60 hertz. So substitute here in the equation and get the value of d squared delta over dt squared, which is the acceleration. So we got now the initial acceleration if a short circuit started. Last point, calculate the power angle at 12 cycles after the fault occurs. Is the power angle going to be the same, شباب, or it has to be increased? This is what we should check here. طبعا because we have acceleration, so we expect to have increase in power angle. So let's see now how we can get this power angle after certain period. طبعا it's stated here certain period of 12 cycles. طبعا 12 cycles for 60 hertz, which is 0.2 seconds. So we can now, شباب, use the relation here of d squared delta over dt squared and make integration for this relation for 2 times in order to get delta. You will find that here you have d squared delta over dt squared equal 30.16. So make double integration for 2 times. You will find that the same constant t squared over 2 plus initial value of delta, which is the initial value before of fault. So we can say now, شباب, we have the constant is given here. At time, we have the time which is 0.2, so 0.2 squared over 2 plus initial value in radian of delta. So you can find here the angle will be 1.06, which is equivalent to 60.9 degrees. So this means, شباب, after few cycles, after 12 cycles, the power angle has increased because of the short circuit we have it here. And if you increase the time, you expect higher angle. صح ولا غلط يا شباب؟ مظبوط يا شباب؟
Yes.
طبعا for that it's very important to clear the fault as soon as possible in order to avoid reaching the maximum power because it may damage the machine. تمام يا شباب؟ يعني this is very very important. So this يا شباب was اتفضل.
In part B, you said that during fault BE equals 0.
Yes.
I didn't understand why is that.
Why? We have short circuit, is it right?
Yes.
We have short circuit on the bus bar. So what is the voltage of the bus bar?
0.
Exactly. Voltage is 0, so power equal VI power factor. صح? So it has to be 0 as well at fault. مظبوط؟
Yes, exactly. Yes.
This is in terms of mathematics. But in terms of circuit, let's have a look to the circuit here. This is our bus. What will be the power that is going to deliver to the load if you have a short circuit here? Short circuit here means all of current is going to feed the short circuit, so there will not be any current or power moving to the load. صح?
Yes.
For that, we consider all of time the electrical power that is going to supply load or transmit it to the grid at short circuit is 0. تمام؟
But there will be power through the ground, through the fault.
طبعا all of power will be feed the short circuit. All of power will feed the short circuit.
So we are interested only to the power that goes through the load.
بالضبط كده.
Okay. Yes.
ها شباب. Any question شباب؟ يعني this يعني was clear. بالنسبة للمسائل يعني we covered most of these problems شباب and we will have a help session إن شاء الله Sunday evening. This was شباب a summary for what we have discussed in all of our chapters. يعني الحمد لله رب العالمين we have يعني covered all of things. يمكن بس يعني only one thing which is the synchronous reactance identification, which is the open circuit and short circuit test, and I believe you already familiar with this from 360 course, so we يعني neglect this part in our course. يعني otherwise all of materials alhamdulillah has been covered. So now شباب alhamdulillah we finished synchronous machine. We will have some problems in Sunday. You can now solve all of problems of your homework. I submitted the homework yesterday for you. And start solving, and the deadline is Saturday at February 20 إن شاء الله. يلا. أي سؤال يا شباب؟
يس دكتور.
تفضل. يعني if anybody شباب would like to leave, يعني you can leave because I know the time is due now. The lecture is closed. I will stop recording, and if you have question you can stay. تفضل يا شباب.